Hello, welcome back to Blender and Sverchok Add-On. In this episode, I'm gonna do a little bit of improv. It's based on the math functions. In fact, it's gonna be like a dance improv, but I'm not gonna be doing the dancing. It's gonna be the character that I draw using grease pencil. You might have seen this animation somewhere. I think it's been around for a while, but it seems to be going back. And yeah, it's basically some kind of arm dance based on math functions. And if you don't understand this, it's normal. It's only people who understand the functions and they understand this kind of dance. Basically, the left and right arm is kind of visualizing the graph or the functions that it's usually created when you use these functions. Normally, in math, they represent function using this y equal x, and even that for some people, y equal x is like very confusing. It's actually pretty easy. I'll try to visualize it using Blender and Sverchok Add-On. So let's get started. I'll go to the front view and I'm gonna use view. Actually, don't use front view. I'm gonna use the top view for now, because with the top view we're gonna get the x and y axis, and here in the 3D view you also see the x and y axis very clearly. So I'm gonna start from there. So I'm gonna save. Actually, I don't need to save. I just go right away. First of all, we can actually observe the locations and position in point using 3D cursor. So you can see as I put the 3D cursor somewhere there, it's gonna say almost like 0, 0 in x and y. But we can do it more precisely using Sverchok. I'm gonna use nodes. Let's start with a number. You can use a number or use a float. I'm gonna use float, and I'm gonna use viewer draw. A single number, it's hard to visualize in 3D space, but because we have like a 3D Cartesian, this axis here, x and y, represented by the red and green, we can actually easily place a point. For a single point, you need at least to have a x, y, z value. So for that, you need to have a vector. Okay, so a vector represents a point 0, 0, 0. If I plug this guy in there, we're gonna see there's a single point at 0, 0, 0. So that's pretty basics. And if let's say if I want to make like if I don't want to put the points at 1, 0, ignoring the z, I will just leave it 0, just ignore it. We're just gonna look at the x and y. If I put this number into the x, for example, and start dragging, you will see that it's gonna run through the x-axis because the y is 0. Okay, so this is actually it's gonna be the first things to understand. So I will provide some kind of range of number. Instead of a single number, I will use range of number. So I'm gonna put it like between 0 and 10. I'll have like 10 points. If I plug that into the x, I'm gonna have 10 points. And this is gonna be something that represents the left arm of the character. If you look at it, if the character is looking to the front, so in order to make this more clear, I'm gonna draw with grease pencil. So this is our character, just a happy looking character, and the body is gonna be like that. Okay, this is gonna be the arm, the white axis. Maybe we can put the arm somewhere else later, but for now it's gonna be on the x-axis. So this is with the x value running through like that. Okay, if we start from -10, we're gonna have like a stretch arm. It's gonna kind of stretch between -10 and 10. I'll make the count 11, so there's a center point. And so now what we need to worry is just the value that's gonna be illustrated using the y-axis. In order for this to be more clear, I will actually use a UV connection, and this will create the arm. Okay, this is just a single line represents the arm. I'll switch it to edges. In fact, if I want to make like a real arm, I can simply use skin measure and plug the vertices and edges there, and increase the radius, turn on live. Oops, that's too big. So now I have the arm for this character, and soon we should be able to generate the dance. Okay. I don't know, this character looks like a turtle or something, but anyway, yeah, so I'll hide this skin measure for now, put it in different layer. So just look at this guy. So we start with the y equal 1. So while y equal 1 is like this. Okay, it's the absolute value for the y. So if we put a 1 in y, so y equal 1, actually don't do it there. I'm gonna have a text as well, so it's easier to keep track of what we are doing. So that's the first one, y equal 1. I'll make this larger. Hopefully Blender doesn't crash much. I'm actually updating to Mac OS High Sierra just the other day, and it was Blender, my render doesn't work anymore, so it's really weird. Anyhow, y equal 1. This 1 can be anything, can be any number, okay? It can be 1, can be 2, can be 3, but you can see how the function drive the curve. Okay, you can put it somewhere, you know, y equal -2, so the arm is a bit lower, but don't worry about that too much. I guess y equal 1 is not too interesting. The next one, y equal x. That's the interesting one. It gives you like a diagonal kind of curve. Y equal x. That's actually, if you plug this guy in there, right away you're gonna get that arm, and you can control the length of the arm like that. I'll just leave it -10 and 10 for now. So yeah, if the y equal x, that means the value for the x, for example, the x is gonna be like a, you can imagine the x is always like a range of float of value. In fact, if you want to really visualize it, you can look at the numbers here. So that's the actual number, 11 numbers of the x. So we don't need to care about x anymore. The y is what we worry. So if y equal x, I just plug in the same data into y, and then you get this. So that's pretty obvious. If you want to use like math here, like multiplier, you can make the arm like kind of stretching that like that. So that's mean like y equal 2 times x, for example, if you put 2 there, or 0.5, 0.5 actually more, a little bit more interesting. So you can have the character doing kind of stretch like that. And let's go back to 0 multiplier. So now the arm is like fully stretched again, back to normal. You can do the y equal -x, which is, of course, -x is like this. Y equal -1 times x. So that's how you can visualize the graph. So you can remember that. And the next one, y equal x times 2. Okay, that's the tricky one. Exponential, let me try. Exponent, okay, this is the x going in there, and it goes to y. Now you have this. Exponent y equal x times x. So get this kind of stretch arm like that. It's actually I might be doing this correctly or not. Let me check very quickly. So yeah, 1 and then 2 times 2. Maybe this should be like normalized, I realize. Yeah, I think it's more like that. It's normalized value. Oh well, interesting. So let's change the things a little bit. -1 and 1. So the value needs to be between -1 and 1. So in order to get that kind of curve, some things to keep in mind. Well, at least we get that curve anyway. That's for the y equal x times x. And this is kind of similar, just the arm gonna stretch a little bit further. But this one, the more interesting one is this guy, y equal absolute x. Y equal absolute x. Absolute is that when the value of x should never be under, it's not, should have been like negative. So if you use the function here, absolute, where's absolute? This guy. If I plug that in there and this into y, we get this v. So I'll go back to -10 and 10. So we have the v, something like that. So that's the new value, and that's absolute. If you look at the value, you can see it's never goes to 0. So 0, 2, 4, 6, 8, 10. This one 2, 4, 6, 8, 10. Without the absolute, it's gonna be negative. When you get -2, -4, -6. Okay, so that's absolute. Absolute function. Continue. This is the opposite because negative always give the flip of value. So if you multiply the absolute with negative, you get this. So it's pretty obvious. It's very easy. It's pretty cool actually. This V shape, upside down V shape, give our character a very nice kind of a exercise motion. It's a dance motion, so at some point I'll use music, but not gonna do it now. So the next one, sine x. Okay, sine x. I think the nice way is, the good way is to actually give the value normalized between -1 and 1, but I don't know. Don't worry about that. I'm gonna use the sine wave anywhere. Sine, okay, sine goes in there. This plug into this guy, and we should get some kind of sine looking arm. So it's not, I'm kind of adjusting the value here, the interval, or yeah, but this value right here, now we have the arms doing the S, kind of like this sine wave. It's actually a nice thing if I have two arms and separate the two arms. I'll probably do that at some point. For now, I'm gonna show you that if you use multiplier after the sine, you can kind of do that flipping of the arm, and if you put the multiplier before the sine, you can make the arm more like wiggly. So let's try -5 and 5, and yeah, so this is like more like a kind of a break dancing. In fact, if you use an add here and offset the value of the x, you're gonna have the arms kind of doing this very nice wave kind of pattern here, like a curve. See, that's actually very hard to do if you're doing like a real dance. That's actually pretty hard. There you go. At some point I'll divide the left arm and the right arm. For now, continue on the E, this function, and there's a logarithmic function, and an E, this one, and this one make a circle. Actually kind of funny, but you can do that. I think here as well there's a multiplier for sine and cosine. This guy, sine and cosine. So if we have this sine and cosine, this value goes into this guy, and then the sine x and the cos x goes into the y. You should get like a circle. So the arm make a circle. So yeah, that's it's really what this is all about. let me try to make the arm slightly bigger. So let's go back to this. I think I should kind of slice the arm and make it like a two kind of data. So we know that the whole functions from here, from this dance, from this y equal whatever x, this mathematician dance is already very clear now. But I just want to make the arms, the left arm and right arm separate. So I need to do it inside Sverchok. For the left arm, let's make it between 0 and 5. Count 10. Okay. If I'm not wrong, I can simply just list join it. So I just need to have two of this. So I have two, and then I'm gonna join this value here. Hopefully it's gonna make our thingy. So it's gonna be like minus 5 and 0. And so yeah, it seems to be working. So this, we want to separate. We have two data. Let me try the matrix in, and I want to put one arm right here at the location of 3D cursor. So I'm gonna use vector in based on 3D cursor, and I have another one, and I'm gonna join this as well. So I'll try separate it for now. So that's the first one, that's the second one. Okay, the first one, that one, and that's the second one. So it's apparently, I probably need to flip it. So the first one and second one. Okay, now we have two arms, and I probably can use a UV connection right here, and should get the edge from here. Not sure if I should join it. Let's join. Okay, let's join, not gonna work right there. But anyway, don't worry about that for now. We have these points to represent the arm. So we have our dancing arm, and we can now play with the value. We want to control both of them at the same time, so I'm gonna use a number. Just plug in there. So there you go. Cool. So that's a number for that guy, and this is for the multiplier. So yeah, and the next one's for the multiplier for the sine wave function. There you go. So more amplitude there for the function, for the sine function. This one kind of controlling that, and we also have this offset, just in case the character want to do this wave kind of motion for the dance. So yeah, it's the most interesting dance is from the wave, from this sine x or cosine x, because it's give you this wave. But absolute also kind of interesting. The rest of them is really just it's just the value of y and x. So yeah, that's how you can do this math dance in Blender using Sverchok Add-On. So it's pretty geeky stuff, but if you want to teach functions and you visualize the functions of math to people, this is how you can do it, and it's pretty fun. And of course, this is Blender, so you can always animate it as well. using grease pencil. Okay, so hopefully you find this useful and interesting. Let me know what you think, and I'll see you in the next video. Thank you.